Good morning, good afternoon, and late evening for the people in Asia. So my name is Cheng. I will be chairing the next session with you. So this session, the theme has been titled Visual Tactile Perception for Robot Manipulation. So I guess we're going to talk a lot about manipulation. So I'm not going to spend a lot of time going through my work too much, but we have a number of exciting talk. We have Professor Siokali going to be talking about toward dexterous manipulation with tactile fingers. And he also did very nice work on exogloves. Right. Of course, in the next talk we have is Professor Edward Elderson. And he's been referred to a lot this already in entire morning about the gel site. He will be explaining to us about the exploiting high resolution tactile sensing for manipulation. And I have a different talk title towards future camera-based tactile, something like that. There's another title on that. And then we'll have three spotlights session talks for 3 minutes, and then we'll wrap up. So I think many of us will just talk about some of our own work, the session chair. I will only give you a couple of slides. These are what you see on the screen is the latest toy that I created with full tactile. I'm a system guy, so when we talk about tactile, we like to think about the whole process. The sensing, the perception, the control, and the action and the interaction. These are two humanoid robots that we built recently. We have one full-size humanoid robot and one industrial-like humanoid robot. And what is important is our target has been full autonomy. So the tactile skin you see on there, on the humanoid, we have more than something like a square meter of tactile skin, and it's all the computation, processing, everything, and energetically it's on board. And then you get full modality similar to human, proximity, vibration, temperature, all of it is already been applied on board. Okay. I just want to give you two examples of such work. Recently, we just a week ago, we published dancing with a humanoid robot, okay? The box dancing. So this is full tactile interaction. The whole body, the human and the robot are reacting to each other, okay? And what is important is we have all the information that you gather on all the modality that is processed simultaneously. And what we are showing is that this control strategy, we can actually have everything done in real time. And these are just taking two strategy. I think we're using sometimes the robot is leading and sometimes the robot is following. And then the architecture take care of all this processing. And this is another example of dancing with another person. So you have full body interaction. So these are much more reactive system. But more recently, we tried looking at how do you process simultaneously all the information with contact, with dealing with surrounding environment in a dynamic manner, and also at the same time allow collaboration. Like imagine somebody needs some help to put up a poster while reacting to the environment and the robot interacting with the person with tactile, and then try to help, just help paste the poster onto the wall. And the robot will react extremely dynamically while dealing with all the tactile information and all the sensory information. It moves out of the way when it needs to. It gets pushed out of the way and react to it. So these are just two new examples that we are exploiting how to deal with multimodal interaction for control and perception. I will not talk anymore. So this morning, Caspar mentioned that he's hosting IPA 2023. I'm hosting Humanoid 2020, but in 21. Okay, that will be in July. We cannot postpone it any longer, so that's where we will be hosting the conference virtually in Munich. So that's my wrap up, and I'm going to let Professor Sikali to share his screen, and I'll stop, and I'll let you take over.
Okay.